Welcome to this deep dive on locking down your SD-WAN fabric. Today, we're really going to get our hands dirty, walking through exactly how you can deploy application-aware firewalls and intrusion prevention right on your WAN edge devices.
All right, let's jump in. First, we'll build a solid foundation with the firewall, really digging into its components and policies. Then, we're going to layer on a really smart threat detection system with intrusion prevention. And to wrap it all up, we'll look at how you can monitor everything from a single unified dashboard.
So we're starting with the cornerstone of our security, the application-aware enterprise firewall. The secret sauce here, what makes it so powerful, is its use of a zone-based model. This lets you logically slice up your network and get super precise control over your traffic.
This picture really captures the core idea perfectly. We're creating these logical bubbles, these zones, by just grouping our VPNs. So your employee VPN, for instance, that becomes the inside zone. Your guest Wi-Fi, that's the guest zone. Simple, right? And then the rules tell you what traffic is allowed to go where. That first rule is absolutely key. It sets up a default deny posture. In plain English, it blocks all unsolicited traffic from the outside. No invite, no entry.
Okay, so now that we get the why, let's talk about the how. We're going to break down the pieces that make this whole zone-based firewall tick. We're talking rules, actions, and the policies that tie it all together.
One of the most important concepts to get your head around is stateful inspection. Look, instead of just looking at packets one by one, a stateful firewall remembers the entire conversation. So when someone on the inside connects to a website, the firewall makes a note of that session. That means the return traffic from the website is automatically allowed back in. It's so much more secure and way more efficient than having to create a separate and frankly risky inbound rule.
Building out a policy really comes down to these three core steps. First, you create your rules. This is where you define what you're looking for. Maybe it's traffic from a specific app like Salesforce or from a certain IP address. Second, you put them in order of priority. This is critical because the firewall stops processing as soon as it finds a match. And finally, you apply these rules to a specific path, what we call a zone pair, like from your inside zone to the outside zone.
So let's look a little closer at the actions you can take. Inspect is going to be your best friend for most situations. It's stateful, it's smart, it's secure. Then you have pass, which is more like a simple gate. It lets traffic through without tracking the session, meaning you need another rule for the return trip. And drop is, well, it's exactly what it sounds like. It just silently throws away any unwanted packets.
Okay, we've got the fundamentals down. Now let's explore the three different ways we can apply these policies. It really all just depends on where the traffic is going. Is it staying within a zone? Is it moving between zones? Or is it trying to talk to the router itself?
Here you can see the two main policy types side by side. On the left, you've got intra-zone policies. These handle traffic that stays inside a single trust area, maybe between two different departments that are both in the employee zone. Then, on the right, you have the interzone policy. This one is super important for managing any traffic that crosses those trust boundaries, say from your secure employee zone over to a less trusted vendor zone.
And we can't forget about protecting the router itself, right? That's exactly what the self-zone policy is for. It basically treats all of the router's own interfaces as one big protected zone. This gives you incredibly fine-grained control over what's allowed to communicate directly with the device, like for management access or those crucial routing protocol updates.
Now, a quick heads up when you're configuring a self-zone policy, and this is a big one. There's an invisible drop rule at the very end. So what does that mean for you? It means you have to explicitly permit any essential control plane traffic. For example, if you're running OSPF for routing, you absolutely have to create a rule to allow it. If you don't, you could accidentally bring your whole network to its knees. So be very, very specific here.
And here's where it all comes together. Inside Cisco vManage, you're not just typing commands, you're visually building the policy. You can see the whole flow here. You define your source and destination zones to create a zone pair. Then, inside that pair, you add your ordered list of rules specifying what to match and what to do with it. It's a really logical, top-down workflow that makes a lot of sense.
Okay, let's pivot. Now we're moving to our second layer of defense, the intrusion prevention system, or IPS. This goes way beyond just allowing or denying traffic. Now we're actively hunting for threats. And it's all powered by the industry-leading Snort engine running right there on the device.
You know, imagine a security guard at a concert.
They're not just checking tickets, they're actively scanning the crowd, looking for known troublemakers from a list. That's pretty much what IPS does. It uses a constantly updated list of threat signatures to spot and block known network attacks as they happen, in real time.
Now, it's really important to know that this advanced feature does need a bit of muscle. To run IPS, your WAN edge devices have to meet these specific hardware and software minimums. And the reason for that is the Snort engine actually runs inside a virtual container on the device, and it needs enough memory and storage to do its job effectively.
So let's get into configuring IPS. When you're setting this up, probably the biggest decision you're going to make is finding that perfect sweet spot for your organization, that balance between raw network performance and just how tight you want your security to be.
This slide lays out your options really clearly. You've got connectivity, which uses the fewest rules to make sure speed is the top priority. On the other end, you have security, which enables the most signatures for maximum protection. But yeah, that can affect performance. And then right in the middle, you have balanced, which is a fantastic choice for most deployments. It gives you really strong protection without a huge performance hit.
This is another one of those really critical design choices. What happens if the Snort engine itself runs into a problem? The default setting is fail open, which puts network uptime first. Traffic keeps flowing, it just doesn't get inspected. The opposite is fail close, which puts security above all else, dropping all traffic to make sure nothing uninspected ever gets through. The right answer here really depends on your organization's risk tolerance.
And back in vManage, setting up the IPS policy is actually pretty intuitive. You can see here you just give the policy a name, you pick your signature set, like balanced for example, and choose your inspection mode. Then you just apply it to the traffic you want to protect. The whole thing is really designed to be as straightforward as possible.
All right, so after we've configured our firewall and IPS policies, the final, and let's be honest, ongoing step is to monitor them. This is how you check that they're working the way you expect, and it gives you amazing visibility into the threats that they are actively shutting down.
The security dashboard in vManage gives you a great bird's-eye view of what your firewall is up to. You can easily see the trends for both inspected and dropped traffic over time. See that sudden spike in dropped packets on the graph? That's a huge signal that something needs a closer look, whether it's a potential attack or just a simple network misconfiguration. And this is where you really see the payoff for setting up IPS. The dashboard shows you exactly what threats were detected and stopped in their tracks. You can see the signature hits broken down by how severe they were, and right below that, the specific threat that was triggered. I mean, look at this. We've blocked thousands of DNS requests for a known malware domain. That is powerful, actionable intelligence right at your fingertips.
So what's the big takeaway here? It's that by combining a zone-based firewall for access control with a signature-based IPS for threat detection, you create this incredibly powerful layered security posture. And the best part? You're doing all of this right at the branch edge, close to your users and right where the threats are most likely to pop up.
And that kind of leaves us with one final thought. We've seen just how powerful today's on-box firewall and IPS can be. But as threats get more automated, even AI-driven, what's the next step? How does this integrated security that lives inside the SD-WAN fabric itself need to evolve to keep up?